and our extra, designer and documenter working hard to make that clear to a potential user.
Okay. And so, well, I guess we have the crew here, so we should just get this party started.
Did you get Andrew yet? Let me see.
Hey, Sponette.
Hey, guys.
How's it going, man?
Let me see. Let me know.
And who else do we have on here? Fellow Jister.
Maybe it's Pavli.
We're getting Andrew from my team. I'm just not sure if that's him.
Yes, that's me. Hi.
Oh, cool. So Andrew, do you want to introduce yourself? And let's just do a round of introductions because I don't think Andrew's met any of you guys.
Yeah, so I'll start. I'm Griff Green. I work with Giveth and have deep roots in the Ethereum space, to say the least. And I'm trying to be like product owner-ish of the Common Stack and just the driving force pushing everyone to get it going. I'll pass it to Jeff.
Hey, I'm Jeff, also working on the Common Stack. I think we actually crossed paths at maybe the last TCR. Oh no,
the beta.
Yeah, the beta call. Yeah. So I'm working to translate a lot of these concepts into easy to understand English, or as English as the crypto space gets, so that we can start deploying some of this research into components that can really move the space forward. And I'll pass it to you, Spotted.
Yeah, so I'm more one of the technical profiles. So I've been contributing some to the code of on the implementation parts of it. But for me, it's also like a lot of things are still moving. So that's basically my contribution. I'll pass it to Zarga, maybe.
I'm Zargam. In the Common Stack, I am essentially the system architect. I do research on CEO and founder of Block Science, and I'm super excited because that's my main channel for taking this research to what I would consider social good, and not just using it to make companies money or whatever that we have to do to keep existing.
All right, and I'm Andrew. I work for ZA at Block Science, and I'm a data economist over there. Do CAD modeling and things like that.
Cool. So for this call, since so Jeff and Griff have seen the current state of the CAD model, that is what I consider a high-level view of the Common Stack goal. It's a model with a bonding curve and the conviction voting and funding allocations in it. I'm going to pull it up quickly and sort of give probably the 5-minute version for Spunnet's benefit. And then after that, I want to have Andrew talk a little bit about what we've done already and even demo the wrapping of a model into a web service. So literally what I'm proposing here is that we take a version of the model that I'm about to show you, wrap it in a microservice, and make it available as a demo of the Common Stack, sort of kind of push us forward. I'm open to a lot of, hold on, let's see, share screen.
And I have to hop off in about 4 minutes, so I apologize in advance. But I'm really excited about the idea of trying to use CAD, trying to integrate a front end to a CAD simulation so people can understand the real value of what the Common Stack is trying to offer, because CAD is a major piece of it. And I'm pretty sure that if we try to go the smart contracts route, well, it won't look pretty, because it's just a POC.
So given that I only have 4 minutes with Griff, then before I go dive into this, because Griff has already seen it, basically what I'm saying is that we can use the CAD model that I already built as the backend to a demo where it represents not the contracts, but rather something much closer to the user experience of the final design, and not in a necessarily low dimensional way. That CAD is literally showing us the system design in practice, as opposed to the implementation of whatever components we have implemented at the time or have prototyped at the time. So the goal here is to find the right I would say, like, way to leverage the assets we have in order to build a great story for the system that we're building that people can get tangible experience with, rather than just like reading articles. Does that make sense?
Yeah, I think so.
Definitely.
Oh, and by the way, I am live streaming this. I should have said that. And recording it, it goes on. Giveth transparency. But
Yep.
Does that end?
yeah, if I leave it, keeps going. But if I would prefer it, I would love it if you would close it and the stream, Jeff, and I can show you how.
Close it right now and start it again, you mean, or at the end?
No, it'll keep going even if I leave.
Okay, so just hit stop at the end.
Yeah.
Can do.
Awesome. So this model is gonna be, well, actually, shoot. Then let me start the same place I started, since again, I gotta use a different diagram to start. So let me, now that I think about it, I apologize. I'm gonna bounce to some context filling, which is, how do I do this? Chrome tab, DAO, share. Cool. So this diagram, which is this is a high-level design view of Commons. It's not the only one, but it's very much the one that we're trying to get to in our deliverables. It is as a third or fourth iteration. We are going to have the augmented bonding curve as the boundary of the system between the outside world, the DAI economy, which is essentially our fiat proxy, to our internal economy, which has got our token inside the commons that's used for supporting proposals, and which you get for being rewarded when you complete milestones. In the overall design we've discussed so far, we're not totally modeling this whole system in what I'm going to show you, but what we are modeling is the current state of the funding pool, the tokens in the reserve, the proposals, and whether or not they've passed. So the model contains multiple levels of graph, one which is the agents who are the participants, one which is the proposals, and then the cross links between those graphs that represent support for proposals. This will be a little bit clearer when I jump into the model, but ultimately I have a representation of this system that allows us to sort of, feel it out, iterate on designs that's actually pretty rich. So I'm going to go back to Jitsi, switch screens to... do you have any questions about that, Spunnet? I think you might be the only person who hasn't seen that diagram.
No, I think it resonates with me, since there's no new components in my for what I've seen now. I haven't been able to read everything that's on the diagram, but I think it's sort of similar to the blocks we've been discussing before. I think this is more about the approach on how to get a demo implementation going on, right?
Yeah, so I'm moving on to implementation. What I'm saying is that I have a Python system that generates the behaviors of a system like that. So it's made up of this is all code that I'm going to show you now. One of the most central concepts that we can edit, but I have a version here, is the trigger threshold. This is the thing that determines whether a proposal passes. But this is a conviction voting implementation in this. It's saying a proposal passes if it has more conviction than the trigger threshold. I have some plots that sort of show how that trigger threshold is safe, meaning that it becomes impossible to release more than a certain fraction of the funds in one proposal. There's just not enough conviction in the system. This goes to infinity on the right. I'm not going to belabor that part, but this system that runs is based on this trigger function, which is parameterized, so someone could change the system coefficients. But then I ran something that starts with 60 participants, 3 proposals, and a bunch of variables that I'm not going to try to explain right this moment. I can go through later if we're going to use something like this. But this system is made up of proposals and participants, and then the connection. So support is a participant supporting a proposal. Influence is a participant influencing another participant. And competition is whether the proposals are in conflict with one another, i.e. some proposals might be, if you pass one, it becomes very unlikely to pass a different one because they have a lot of overlap. They're directly competing in what they're proposing for. And if they have a lot of overlap in supporters, then they might actually, one passing might lead to the other one not passing. However, the system doesn't preclude them both passing, and it doesn't preclude neither of them passing, because it's based on each thing being treated separately, and it's passed by itself. It's whether or not there are enough funds and enough support to pass both that actually matter. So it's a neither A and B, A or B scenario, not a pick one voting scenario. Then we have sort of reserves and funds and sort of all of these variables, which I will quickly review when I get to running it. But here's a quick plot of the social network that was generated. This is again a sort of randomly generated network. It initializes. You can set the seeds, so it's exactly the same, but I'm not currently using the CAD feature to set the seeds. So every time I run this, it'll be a little different. Here's my 3 proposals: distribution of token holdings, distributions of funds requested. Again, if you have more proposals, that's a little more interesting. Hidden signals of the individuals are their preferences or affinities for the proposals. This is again, just the initial conditions. So there's the 35 and 3. Bunch of parameters that we can sweep and test. Currently, the only one that I'm varying is alpha. That's the rate. That's the conviction power. So this has to do with the conviction voting part. Bigger alpha means that it charges slower, but charges up to a higher amount. So again, parameters to be played with there. This is going to run it's going to run 100 time periods, which I've modeled at about a day. This is going to run one Monte Carlo experiment. It can be many, but this is to keep it computationally small. When I run it, these are the 3 sets of parameters that get run. My initial conditions are declared here. The network contains all of that graph information I told you about. And then there's supply, funds, reserve, spot price, and sentiment. That means sentiment is sort of a global variable that influences behavior. So if the system's doing what it's supposed to do, sentiment is higher. Therefore, different activities are modulated. Again, that we can tune. There's certainly things in this model that represent behavior. Therefore, they have a lot of how do we want to model them, but there's a working model in place. It's a 4-step process. First, I do random generation of new proposals and new participants that arrive based on some arrival process. I update the variables in the system. It's essentially got a graph database in memory. That's what the network X is doing. So it's updating all of those variables. Then we see if any of the proposals that have previously been passed to fund actually get completed, and that affects sentiment. We see if any new proposals pass, meaning they have enough conviction to be funded. And then finally, we update the participants' decisions, and they buy more tokens, or they burn tokens, they choose their voting, etc. So this is the system model that's embedded. It runs in the CAD engine, generates 3 sets of results. I quickly sort of looked at what happened on the funds on each of the 3 to sort of get a sense that it was working right. This one, the conviction level is much lower, and actually none of the proposals pass if you zoom into that one. This one has some proposals passing. This one has more, because I was just sort of looking at the effect of the alpha parameter. We're going to continue to look at the third one. These are index 0, 1, 2, 3. So the third is going to be set as my data frame. I do some Python data science type manipulations to collect the data out of the graph into tables, and then I can sort of look at what happened. And here, when I put everything on the same axis, we've got sort of different scales for funds, reserve, and supply. We can look at them individually. They have a little bit more change. And this system had it went from about 40 cents to about 46 cents per token. And this system was initialized with the same parameters as Abby's Hatch Sim, actually. So it starts off selling tokens at 10 cents. It results a hash which when it gets launched, it gives you a 39-cent a token price, and then the system slowly grows over the course of this 100-day simulation and actually resolves to about 46 cents. Anyway, sorry, I got distracted by a thing. Okay, cool. So I did a couple things. I checked the invariant. So I put the data from the run on the invariant to see that that has to do with the bonding curve properties. I went and looked at the actual private signals. This is hidden information, but it's how the participants decide what to support. So you have at the end of this simulation, there was quite a few more proposals, quite a few more participants arrived, and there's a preference of every participant for every proposal so that we can resolve the sort of the variables related to the agents, whether they're happy, what they vote for, etc. The system dynamic that actually occurred is summarized here. We've got the candidate proposals rising, and then when they pass, you see them become active and go down. In this case, one proposal got killed early on. This means that there wasn't enough support to keep it as a candidate. So if you don't have enough support at all, then you get killed. Doesn't happen that often the way that I have the simulation set up, but we would definitely expect some proposals to go away simply because they stopped being supported by people. The active count is projects in the works. Completed are the ones that are completed, and there are random variables that allow for projects to fail. So we can, again, if there's lots of failure rates, then that influences sentiment, which undermines the system in another way. So we're kind of able to look at the system with different parameters like success rates, failure rates, and sort of there's a lot of stuff that we have to pick in order for this to make sense. But at the same time, we have the capacity to explore from our design work what these values should be. From a narrative side, we can make decisions in order to show it's how we are designing it to work will basically show the system's evolution. There's not that much more. I can generate videos even. I'm doing it in a really hacky way because I'm not really expert in that. But I did a sample video where I ran this plot through a whole run where these dots are the holdings of, these are the agents, these are the holdings of the agents. These links are the amount of support for the proposals. The proposal size is the amount of funds the proposal are requesting. And over time, you can see the color code is the state. So a candidate is blue, a killed is black, which is why this one turned black. Yellow is in progress, green is completed. And so you can actually look at the 100 frames of this to see the system evolving dynamically. And I did some other summary plots, but the point here is that I actually have a system level representation of this DAO, this commons. It can be tuned, manipulated, changed. We have a lot of work to do on it to really, guide the creation of the thing. But from a storytelling perspective, I'm really gung ho about making this available to people who want to understand what we're doing. There's a couple ways to do that. The easiest one that we've already done is to just be able to allow people to run these simulations from a web app. Slightly harder, but potentially better long-term would be to mock something up that makes it a bit like a game where the system's evolving and you get, as the user of the app, the ability to actually make some decisions at different points and see how your decisions influence the way the system evolves. And so with that, I'm going to pause and say, Andrew, why don't you show the demo of the three-sided market that you have running right now, just to give a quick sense of the fact that we've actually already ported things from Python notebooks into web apps. So I will stop sharing and let Andrew share his model. And actually, by the way, if you have any questions, Spunnet, feel free. We're just trying to basically position the use of the model as a tool for narrative and for teaching and for helping people feel what we're building. And I think it serves the user story better than trying to get Solidity prototypes available, just because we want to get feel right, not just the say here's the current version of our
Yeah, just to comment on that, while the other demo is gearing up, I think it's very beautiful. All the simulations that you've shown so far. My only question would be, yeah, what exactly can we add on top of that? Because all the stuff you have in this. In all these simulations, they allow us already to do these simulations, albeit that they're not interactive yet. So they're just like static. So you just run it once and then it produces a result. So that's one thing I could see, that it could potentially add some interaction so that users can actually like manipulate or like interact with that model. So that could be a big benefit, of course. On the flip side, I think it might. So once we start like creating a front end which taps into that as a like exposed as a service, which I think, by the way, is perfectly doable, is how much will that be always a moving target? So like if you change things on the math side, probably it also has some implications on the front end side. So that might be one of the fears I would have in implementing that.
Can I want to comment on the two things that you just said, and then I'll give it back to you. Yep. So the first one is, I'm very much enthusiastic about making it interactive. I have some thoughts about that from the CAD perspective. As long as you store the final state and use it as the initial state, it should actually pick up right from where you left off. So there's a little bit of a technical question about how best to do that from an API standpoint, but the system itself should be very, very capable of actually stopping and starting because it's effectively stateful. And then the second comment was regarding the crap. This is why I wanted to do it before, like at one thing at a time. What was the second thing that you said?
Yeah, that it might be a moving target in the sense that if the math changes or like the way it's like results are produced, that might influence the output and then also the front end.
So it will some, but we're working on trying to bound those component relations. So like the work that Andrew's been doing he's already versioned the model that we're going to see once or twice, because there's it's a relatively nice decoupling between the changes to the front end for simple math changes. But if you want to change the states and what they mean, absolutely. If you want to change the logics, it doesn't. So there's going to be like a level of things that absolutely change the front end and some that don't, but it should converge pretty quickly because it's more about the concepts that matter, that they're going to be named the same thing. They're going to be available in the API, and they're going to be the things that we plot. And even if the maths and the logics change behind the scenes, the resulting visuals, the things that people care about, shouldn't change very much. And sorry, so continue. I like to do one.
Yeah, I understand. I think my final concern would be that, like in the end, the goal is that we use the power which like a decentralized network offers us, in the sense that I think one of the most compelling things is that you can actually manage funds with such a thing. So it's safe to actually send tokens that have a certain value in exchange for these voting tokens and so forth. So that also implies that in the end it should be implementable in like to run on the EVM. So either in Solidity or in Viper, but we should be able to squeeze it through that hole, let's say, or to these limitations that the EVM has to actually run it.
So the design iterations here, think of it as the requirements, not the algorithm. So in engineering, like higher level design systems, like you're working on robotics and control systems, your models of the world are not their implementations, but the models have to share requirements with the implementations. So in a sense, if we say the bonding curve is preserving this invariant, then the most important thing about the model of the bonding curve is that it preserves the invariant. And the most important thing about the implementation of the bonding curve is that it preserves the invariant. So the property that the model enforces about the invariant, about the bonding curve, is that invariance. And so there's a formal mathematical relation between the model and the implementation, but it is not that the model is the implementation. It's that the model and the implementation share the design requirements. Does that make sense? And
Yeah.
so we have to work through that. I mean, in some ways, this is an example of us trying to prove our methodology out in a transparent way. We're saying, look, in parallel, we're creating an implementation and a model. The model allows us to design the system to have intentional behavior, even though it is at a different level than the implementation, and to iteratively marry the two. So if the model is not implementable for some reason, and we say, well, we can't do what we wanted to do, we have to do something else instead. You say, okay, well, what are the implementation bottlenecks? Oh, okay, we can't implement log. Like this literally already happened. I had a log trigger function, a barrier function. And through discussions with the Solidity people were like, well, this isn't going to be feasible. We can't implement log. So I used a different barrier function, which is 1/1 minus the thing squared. So it's like a electron repulsion type one, which has the same mathematical properties that I needed for the trigger function to have a asymptotic limit on how much you could withdraw. But instead of using a function that wasn't going to be implementable in Solidity, I changed the model and tested it using the CAD and said, okay, yeah, actually, those heat maps are actually there to demonstrate, the ones at the top, to demonstrate that the alternative logic for the trigger function was going to work from a systems requirements perspective, and also, you know, a pivot towards something that was going to be more implementable in Solidity. So that's exactly what this is there for, is to allow that hybrid iteration between, okay, I ran into an implementation consideration, I want to make a change, okay, let me make the change in the model, how does that affect the model? Okay, that's still cool, go ahead with it. Or, oh crap, that screws up the properties, let's think of something else. And so we want actually to have both, but I'm thinking that this simulation model as a sort of thing that we could put forward will have a lot of bang for its buck in terms of attention, in terms of demonstrating the method. Like a lot of our narrative surrounds the things that, well, literally what I just described, that iteration. And right now that's really hard for people to get. They're like, they just like, well, why don't you just make it and see if it works? And I'm like, well, one, a Solidity iteration is a lot harder than a CAD-CAD iteration once you have a CAD-CAD model. Two, the Solidity iteration cannot reasonably capture the things that are outside the scope of the EVM. When you're talking about a human system, we still also need models of behavior and models of concepts that are actually not on chain, like those private preferences. Like I built a model to randomly generate them to look at decision making, but like if we had to do something that showed the system's evolution, it can't really exist without the notion of people's preferences. But that's never going to exist explicitly in the smart contracts. You would need a whole nother system anyway to serve as the like complement to your smart contract implementation and then your behavior logic to laminate with it in order to run experiments. And actually, I would argue that, you know, late stage testing should be exactly that. But early stage testing is driven by models, and that version where you connect models to EVM code, to the actual smart contract code, I call that hardware in the loop testing. It's like you take a social model and connect it to implementation. And in engineering, I mean, I literally took the hardware in the loop term from that. You connect a piece of equipment that you built to a system model a level above it and drive it to see if it does the thing that your model said it would do. So you do a comparison test between your modeled model and your partially, like, sort of your hardware in and your decision logic out. And so, again, we kind of got a long roadmap in front of us, and I'm mostly attacking this from a question of how do we best show what we have done, what we are doing, what's different about what we're doing, and I'd like to see us leverage this model that I sort of made it. I've been using my evenings and weekends to make it in order to facilitate the narrative work of Jeff and Abby. And I'm now realizing that it has some potential power, beyond that. And I don't have the time or the energy to build out all the documentation and everything until we produce basically funds. But I do think that I can hand off the running code in a web service so that we don't have to basically spend as much time making the code speak as code, but make the code speak as running code. showing what it is. And with that, I'm going to shut up and let Andrew show you guys how we make models, like actually into web services.
Okay, will do. Can you hear me and see my screen?
Yep, all good.
Okay, awesome. So what we have here is it's a packaged REST API in a Docker container. I can show some of the code as well if you'd like. There's the web server address here, and we can give you the password if you'd like. But essentially what we have here is just a bootstrapped UI here, where we have example. It's one of the tutorials for CAD you might be familiar with, where we say what some of the starting assumptions are here. And then we have the high-level graph here, and then we have the mechanism steps that we've designed that show how everything, the behaviors, mechanisms, and states, and how everything interacts. And we have several variables you can change. So these are suggested values, but you can change them a little bit. Finite supply of tokens. Let's just say we're going to do 2 million today instead. The 1 million suggested, and then conversion rate. We're going to say starting it's 50 cents instead of 1. And then these are all the little things we can run. And then this is going to do 5 Monte Carlo runs. Just takes about 20 seconds. And for speed, if we want to do more, we'll look into caching over time, or increasing the speed of the instance that we're using. So now it's loaded here, so you can see the different graphs of what we're the fiat token and reserves, the price ratio here. You can see what happens to the price, volume of production, producer cost, producer ROI estimate. And then so what's a really cool feature here is we can hit this button. We can download the data. Let's take a second. Here we go. And look at the data in CSV file. So you can then do whatever stuff you want to do in Excel or whatever. So it's just a very simple way that we package this. Oops, wrong window. That you can easily pick a UI. You can make a fancy UI here. This is just very, very basic bootstrappy. But all I'm doing is running a Flask web server and running a the whole CAD simulation is a function, and then it's being called into the respective. This is just a regular HTML. There's no JavaScript or anything here. Form that you submit the form and pass the variables through Flask into CAD and then return those results as a data frame. And you can even have a curl command from this or anything. And you could technically have a Python program and do just a requests and run it all that way without the UI as well. Are there any questions?
I think it's very useful here. So what we're aiming for here, just one clarifying question here is: so the graphs that you're showing at the bottom, are they like rendered client side, or is this also something that you fetch from the REST API?
Yes, so this is fetched from the REST API. So essentially, what I'm doing is when I run the file and then post this result, the result page actually in the back end saves the image to a file on the server, and then the server shows that image.
Okay.
So like if you're doing the curl, you obviously don't get the image, but yes, this is being generated exactly on runtime and being all handled through the web server.
Yeah, because I think one of the approaches we could take is to if the REST API actually spits out the CSV value, so to speak, or maybe like segments of what we need of that, then we can also run that like client side. But I don't know if it makes a lot of sense, because we'll have to wait. If we recalculate values, we'll have to wait for the answer of the REST API. So it's not like it's going to be dynamic, like if we if you would make a slider out of the total supply, for example. It's not that you will see that the graphs go up and down, because it needs to run.
So let me suggest two things. One is that for something that we might do where we want to limit the amount of degrees of freedom for sliders, I was actually a big proponent of actually just pre-crunching almost everything and using the data, basically put a database behind it instead of, like, you don't even actually have to have the model behind it if you don't want. You could literally run a bunch of experiments, dump all the results in a well-defined database, and then literally just do the front end from the database. Because we can produce the data, as Andrew showed, and dump it. So it's not even that we have to do it as CAD in a web service. We have, so there's a couple different ways to think about it. My bigger thing was just like kind of getting the demo in front of you guys, I was going to ask Andrew to show how this is set up with the code, because I think there's a lot of reason. It's actually very simple. So there's room for you to think of, if you see how it works, you might think of, oh, I'd rather do it like this. I'm going to change 2 or 3 little things, and then it's going to do what you want, right? This isn't a really sophisticated thing that you're not going to be able to manipulate.
Exactly. And here's what you have right here is how I'm just sending this. You don't have to have that UI or anything if you wanted to have a backend like this, and you can also run this through curl, where I just have the different variables. I pass in the data here as a dictionary. This is our password here, block science, very innovative password, as you can see here. And then I just hit it here and return the JSON and pop it in the data frame. So I'm calling right here without the front end, because the REST API runs in the background. You don't have to use the front end at all. And then it returns the results here.
Yeah.
You could even pass in however you'd want the data.
Yeah. As Zargo, do you think it's feasible to actually pre-calculate all these numbers? Because like in the experiment we just saw, I saw at least, I don't know, 10 variables. So you have like 10 dimensions of.
It's actually even higher dimension than that. Essentially, to realize that like the actual raw model is got like essentially it has a graph database in memory. So like, in practice for this particular model, we'll have 2 choices. One is to sort of run it the way that Andrew just ran it. And if we did 1 run, it's still probably only in the few seconds range. And I think it's still pretty cool. The second thing is that we could essentially start with, again, like just running it a dozen times and giving them 1 slider and saying like, cool, but we have cached all the results from all of the runs, and then they can just like look at it. This is part of the reason why I wanted to get on this call, because we have what I would say are a lot of assets, but we don't have the ability to just say, I could theoretically just take what Andrew's already done, wrap the model I just showed you, and say ta-da, but I don't think it meets the needs. So it's almost like a product question with the limitations being at the development level. So like it's the product question from like Jeff's perspective, how do I tell this story? And then from our perspective, it's like, here's all the assets we've already produced. And then from your perspective, it's, okay, what's the technically feasible way to leverage those assets to meet the storytelling goals?
And for a quick recap on this is a 5 Monte Carlo run. Z's talking about a single one. And this is running on a GCP with a server that has like 1.5 gigahertz and 1 gig of RAM. So this is very, very low. Like if you had something that required more, you could just juice up the underlying server and go a lot faster.
We got to be careful with costs, because you might get a lot of runs. So that's the other thing that I like about the caching solution in the short term, is that I'm worried that if it does blow up, we're just going to crash the server. Like if suddenly it got memed, then we would be either having to support massive loads on the cloud, or we would need to or it would just go down. And so I think that the sort of lowest hanging fruit for version 0 might actually be to just do runs and cache results and make a front end for it. Because we would hope that this would kind of catch on and a lot of people would run it and a lot of people would look at it and a lot of people would play with it. And, if we then asked bigger questions about how to get the sort of running model, I don't know, like we can solve other questions later. My first goal is to just make a systemic understanding of what we're doing low friction for someone to access. Just like get them to see and feel what this design is, and hopefully get them excited about it to support us doing the work that we need to do to make it happen.
Sounds good. And unfortunately, I gotta drop to run to get ready for another meeting.
Okay, cool. Just make sure, Jeff or Spawnette, if you have specific questions for Andrew, he's in the Telegram group for the CAD, and we can get you in touch if need be. But mostly, I'm hoping that if we can do something, it can be done predominantly with lightweight support from myself and Andrew. But let us know.
Yeah, and I can hang on here for until 50. I just have to quickly run something before, so I can be here another 8 minutes if you have any questions now as well.
I think my main question would be like, we can. I don't think we need to worry about these caching issues right now, because I also think that if people start playing around with it, we could also sort of do some like you would do like lazy loading. If people change the parameters and you run the simulation and then you cache it, and then when someone else by accident uses the simulation with the same parameters, you just serve the cached version, so you don't need to run the whole space beforehand. I also think I might also put it as a question, because what exactly do we want to propose or want to show or want to explain to people when they visit that site? Because I would assume that it's like it's a story they want to see. They want to see like the simulation of something they can sort of relate to. They can imagine a situation where they have like 60 participants and they all like do all that stuff like you showed in the simulations, Argem. But that only makes sense within certain boundaries. I mean, you could also like pull down the slider and say there's only one participant, but then that whole simulation makes no sense probably.
Well, you can control the ranges, but I would say Jeff is the main person who I see as the person to look to give me suggestions for stories, because at this point the ability for me to configure the simulation to match a story is pretty low cost, like low time cost. Like I might take a little bit of time in an evening if he said, you know, here's a bunch of cases, like I could essentially play with it a little bit in the raw version and say, okay, cool, like I figured out how to set it up to represent that story or that class of stories. And to be clear, like we've created scenarios where, for example, nothing passes, and we can create scenarios where everything passes. Like it's a pretty well parameterized space. We're using it to explore ideas. So that's why I was saying in its current instantiation, it's really a storytelling tool. It tells us stories that we wouldn't necessarily be able to tell without it, because it has all of that interaction effects built into it. But we're like, oh, imagine the world worked like this. What happens? And then, oh, wait, imagine, you get the idea. So I'm actually saying from a product in the sort of narrative sense, I think Jeff and Abby are going to have to basically come back to me and say, hey, look, like the one we're running isn't that helpful because it doesn't tell the right story. Like we want you to set it up so that it accounts for these effects and not those effects, and the time scale's about this long, and I can do that. We're really talking about whether or not we can close the gap in terms of, if we do that, like how do we want to make that available to our community?
Yeah. Let me just make a suggestion, because do you have an idea about how many of these microservices we would need to actually run all the simulations you showed earlier? It's just that one.
Yeah, because everything that I just described is in the parameter space.
No,
everything I just said that you can, even the trigger function is a parameter in that one. You can actually make a list of different trigger functions, and it will run the same experiment with the same service with a different function in the trigger.
Yeah. What I could suggest is, how about like, and I could start on that tomorrow morning actually. So if you can make that web service available for me, maybe with a demo that was just shown. I could really like take a stab at making like a sort of a React front end, like we did with the Solidity implementation and the demo that we did during the hackathon. But that taps into that one.
Let's have Andrew get you access to that. I think that it's in a private repo, because it's part of one of the things that we're going to try to do in the future is make things like this to hopefully generate some revenue, because we kind of have that whole need to exist and pay our staff. But we want to make his work available to you so that you can do a version for this. I'm not exactly sure what the mechanics of that will be, but I'll let Andrew figure it out with you. Andrew, you just want?
Yeah, just send me, I'll put my email in here. Just send me an email. And Z, I can also just send, if you don't want access to that repo, I can just like take what I have now and then send it in a zip file or something.
Sorry?
Okay, so I just,
whatever works for me. I'm just like, I'm conscious of the fact that the code that you're talking about is in a private repo, which means we need to actually give it to him if we want him to use it.
right. Okay, so I won't give you access to the repo. I'll just send it to you. So I just popped my email in the Slack. It's andrew@block.science. So just send me an email on that, and I'll get you the code for what I just showed you. And just let me know if you have any questions.
I'm gonna ping you for that as well, Andrew, if that's all right.
Oh, definitely. Yeah.
Awesome.
Okay. Well, I gotta run. I'll see you guys later, and I'll
Hey, thank you very much.
Yeah, no problem. And then I'll send that code to you either today or tomorrow morning.
Thanks, Andrew.
No problem. Have a good one. Nice meeting you all.
And you guys have me for another 10 minutes because I think my next call is also with you guys.
Yeah, we're in this room. So if you just want to stick around, I just had a beer delivered.
Nice.
I
got a beer called the Dark Swan. It's a like black
California
swan
beers.
Like it literally has a black swan on it. It's called the Dark Swan.
To avoid what? Caleb coming after him?
Well, we'll come after anyone. That's his thing, right? No, whatever. Anyway, I mean, not come after people. I don't know that. Whatever. He's just kind of angsty.
Maybe we should say this after we stop the live stream. I'm gonna stop this so we have the recording for our dev team.